Okay, so in the system problems here, we have to determine whether the non-homogeneous system is consistent. If it is consistent, we have to write the solution as a sum of the set of all homogeneous solutions plus a particular solution. So the way to progress on these is to actually build the augmented matrix for the system. So in the first problem here, I have 1, 3, 10, and then 18, negative 2, 7, 32, 29, negative 1, 3, 19, 12, 1, 1, 2, 8. Now, if you feed that into MATLAB and take Gauss-Jordan, you're going to get 1, 0, negative 2, 3, 0, 1, 4, 5, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so this is A augment B, right? So I know in this case that the rank of A, given the two quiet columns, right, is going to be 2. The rank of A augment B is also 2. And if A is an M by N matrix, then N is 3. Okay, so I know that the rank of A, 2, is equal to the rank of A augment B, 2, and that is less than 3. And according to what I know from the notes, this tells me I have an infinite number of solutions. Now, I want to note right off the bat, given this problem, right, this solution here, if I make all of the free columns, make the parameter for them 0, this is going to give me the augmented solution. So vector x sub p, a particular solution, is the solution 3, 5, 0. Okay, so you should be able to see the the particular solution right here in the end. Now, the question is like, how do I deal with the homogeneous parts of the general solution? So I'm actually going to do the homogeneous Gauss-Jordan here, but I'm going to tell you that you can work with this noisy column and pull off what would be the homogeneous parts. And that's how I'm going to do it for some later problems. But I'm going to work it all the way through step by step in this first one. Okay, so let's think about what the homogeneous system would look like. So that's 1, 3, 1, 0. And it's homogeneous, so we're not setting equal to B, we're setting it to the 0 vector, right? 2, 7, 3, 2, 0, negative 1, 3, 14, or sorry, 1, 4, sorry, wow, I'm reading that wrong. That should be 32, 0, there we go. Negative 1, 3, 14, 0, 1, 1, 2, 0. Now, the result of doing Gauss-Jordan on the homogeneous one is just that we get the same result. 1, 0, negative 2, 0, 1, 4, 0, 0, 0, 0, 0, 0, but we get the 0 vector at the end here. Now, if you think about the homogeneous solution here, this reads as x1, right, minus 2x3 is equal to 0, and that x2 plus 4x3 is equal to 0, right? So if I'm solving this, I would normally let x3 equal some parameter, which would now make x1 equal to 2t, x2 equal to negative 4t, and x3 equal to 1. So the homogeneous solution here is going to be t times 2 negative 4, 1. Now I already found the particular solution, which was 350 is a particular solution. So in the end, any solution in the form of t times 2 negative 4, 1 plus the particular solution 350 solves this system. So this system will be solved for every single value for t given those two column vectors. Alright, so there you go. That's a way to describe the infinite number of solutions to this system by using the solutions to the homogeneous system and a particular solution. So let's look at number 2. Alright, so the matrix that would work for number 2 is 3, negative 8, 4, 0, 19, 0, negative 6, 2, 4, 5, 5, 0, 22, 1, 29, and 1, negative 2, 2, 0, 8. If I take Gauss-Jordan of that, I end up with 1, 0, 0, negative 2, 0, 0, 1, 0, negative a half, 0, 0, 0, 1, 1 half, 0, 0, 0, 0, 0, 1. Now, the big tip-off here is this bottom row, which has all zeros and then a 1. That can't be, because you cannot have all the coefficients being 0 and then the value being 1. But let's take a look at how this works with the rank statement. The rank of a with B is going to be 4, right? Because I have 1, 2, 3, 4 quiet columns here. The rank of A is 3. If the rank of A, the A with B is bigger than the rank of A, then this is inconsistent. And the problem has no solution. So we're not going to go finding a solution because we can stop there. Okay, so this is one of the places where the rank helps me, because rather than going in and trying to find a homogeneous solution and a particular solution and all of that, I can just simply stop right there. Okay, looking at problem number 3, the matrix that I'm going to get here is 3, negative 2, 16, negative 2, negative 7, negative 1, 5, negative 14, 18, 29, 3, negative 1, 14, 2, 1. Okay, so again, I perform Gauss-Jordan. I'm going to get 1, 0, 4, 2, 0, 0, 1, negative 2, 4, 0, 0, 0, 0, 0, 1. Alright, again, there's that telltale bad row. So if I look at the rank of A with B, that comes out as 3, 1, 2, 3 quiet columns here, as opposed to the rank of A, which just has 2 quiet columns. So that's bigger than this, which means that I am again inconsistent, and I can stop. Alright, so let's look at the system in problem number 4. This yields the matrix 2, negative 4, 5, 8, negative 7, 14, 4, negative 28, 3, negative 6, 1, 12. And if I perform Gauss-Jordan here, I end up with 1, negative 2, 0, 4, 0, 0, 1, 0, 0, 0, 0, 0. All right, so let's look at what's going on here, right? The rank of A with B is, well, 2 quiet columns, gets me 2. The rank of A also gets me 2, so those are equal. And N here is 1, 2, 3 columns, so that's less than N, which is 3. So this tells me I have infinitely many solutions. Okay, so the solutions here have to have 3 variables. N is 3. Okay, so XP, the particular solution, I can just read from the end there. That's 4, 0, 0. Okay, the homogeneous solution, XH, is going to have, well, it has one parameter, T. Now, that parameter, the only variable that doesn't have a 1 like this in the quiet column is the x2 variable. So we're going to let x2 be equal to 1. This first row, if that was a 0 at the end, would tell me that x1 has to be 2t, and x3 doesn't have that in there, so that's going to be 0, so that is my homogeneous solution. You can work that out by hand a little bit more detail, and you'll see it. So the general solution here is going to be t times 2, 1, 0, plus the specific solution 4, 0, 0, and that's my solution. It's my general solution to this system. So there you go. Very good. All right, so, oops. So let's look at number 5 here. I have the matrix 1, 2, 1, 1, 5, 0, negative 5, negative 10, 3, 3, 55, negative 8, 1, 2, 2, negative 3, negative 5, 14, and then negative 1, negative 2, 1, 1, 15, negative 2. Okay, so I'm going to apply Gauss-Jordan to that, and I end up with 1, 2, 0, 0, negative 5, 1, 0, 0, 1, 0, 6, 2, 0, 0, 0, 1, 4, negative 3, and 0, 0, 0, 0, 0, 0. Okay, so let's look at the rank here. The rank of A with B is, let's see, 1, 2, 3, right? The rank of A, all of those are not including the B, so that's going to be 3. And N here is 5. So 3 is equal to 3 is less than 5. So we have infinitely many solutions. Okay, we are, so we're going to use consistent, right? So the solutions here are going to have 5 values, right? So we can just read those down. 1, 2, negative 3, 0, and in the end, we just make another 0. That's my particular solution. 1, 2, negative 3, 0, 0. The homogeneous solution here is going to have 2 parts, right? It's going to have one for the second column and one for the fifth column. So we'll call the second one T, we'll call the fifth one S. Okay? The second column pertains to the second variable. So that's 1. And the only other thing in that column is the top of it. So that becomes -2. And 0's the rest of the way down. The fifth column pertains to the fifth variable. So that's 1. And then we just change the signs for the other 4. So it'll be 5, -6, -4, 0. And that gets me the homogeneous solution. So for the general solution, can I squeeze it in here? We get that x is the homogeneous solution, t -2, 1, 0, 0, 0, plus s times 5, -6, -4, 0, 1, plus the particular solution 1, 2, -3, 0, 0, and any values for s and t, right? This is a plus, not a t, right? Any values for s and t here will give me a solution to ax equals b. Okay, so we got one more. All right, so looking at the last problem here, my augmented matrix is going to be 5, -4, 12, -33, 14, -4, -2, 1, -6, 12, -8, 1, 2, -1, 6, -12, 8, -1. Okay, so if you look at the last two rows, it's kind of obvious what's going to happen there. But let's work out what happens when I do Gauss shorten. I get 1, 0, 4, -5, 6, 0, 0, 1, 2, 2, 4, 1, and then a row of zeros. Okay, so first off, the rank of A augment B is 2. The rank of A is 2. We have n variables, so 2 equals 2 less than 5 variables, right? So which is less than 5, so I have infinitely many solutions. Okay, so again, solutions here have 5 variables. So the particular solution that I'm going to use here is 0, 1, 0, 0, 0. Okay, the first, so there's 3, the dimension of the null space is 3. So there's 3 rows that I'm going to have to deal with here. So let's call it t times something plus s times something. And I think in the worked out problems I used like w is the third parameter. You can use any letter you want, r, whatever. So this one goes to the third. So that's going to be -4, -2, 1, 0, 0. This one goes to the fourth. So this is going to be 5, -2, 0, 1, 0. And this one goes to the fifth. So this is -6, -4, 0, 0, 1. So if I take and say, running out of space here, let's cheat. If this is the homogeneous solution, then x will be the homogeneous solution that I have here plus the particular solution that I have here. And any values for t, s, and w are going to solve the system ax is equal to b. All right, so if you have questions, email, do the drop-in. I hope all is well. We are, definitely Monday of the week here, and I think this is the last topic we're covering in this unit. So, yay us. All right, thank you.